Good morning. How are you all doing? Good. All right. So my name is Luigi Cosi, and I'm the founder of Oikla. And today we're talking how we can use. Good morning. How we can use digital signal processing to enhance and potentially must prevent hearing loss for a lot of people. So my background, I used to be a DJ when I was 16. I used to blast my hearing with a lot of dance music. And I still remember my neighbor just knocking on my door and saying, "Oh my God, turn it down, it's too loud." Good morning. And after my early teen, about 20, I decided to get into production and, get into the studio. I wanted to know more. I wanted to produce music and so on. And after that, I decided to become a sound engineer. So I decided to move. 10 years ago, I decided to move to London, exactly today, 10 years ago. And I wanted to study sound engineering at SE London. And my first trimester, during my first trimester, what happened was that I started to have, tinnitus and some mild hearing loss. And that was pretty interesting for me because I just started studying, I just started my course, and now I have this beep in my ear, and I thought, okay, it's gonna disappear in a couple of days, and then it never went away, and I got really scared. So I went to the doctors, thinking that there might be a solution, naive of me. Well, there was no solution, You get it, and you're gonna hear it, and you're just gonna hear it. So that's it. That's your problem. And so I was clearly, frustrated because how am I supposed to do now? Like, what am I supposed to do? And so I decided to start Oikla, which is my startup. So I'm sure you probably read the title. And the thing that really bothered me was that I wasn't the only one. I wasn't like just me, a guy who didn't know anything about prevention. It's a thing that affects a lot of people worldwide, or can potentially affect a lot of people. In fact, we're talking about, these are young people. These are not old people. These are people that are between 11 and 35 years old, right? This is the next generation and the current generation as well. So that really, at that point I thought, wow, this is like a global problem. And if we don't do anything about it, we will have, consequences. Maybe I shouldn't move so much, right? But I'm Italian, so I like to move. Do you guys know why so many people are risking hearing loss? It's probably easy to guess, but please interact with me. Anyone?
Everything's too loud.
Everything's too loud? Yeah, it is too loud.
Yeah, headphones being too loud or loud concerts.
Yeah. Yeah, of course. The reason why 1 billion people are risking hearing loss is because of loud sound exposure in recreational settings. And we're not talking concerts and stuff like that. This is mainly, as you were just saying, headphones, loud sound exposure. You just decide, I want to just blast my hearing today, right? And so what are the current solutions? What are we doing to prevent my, hearing loss or any sort of hearing problem today?
The last little things are read on my iPhone.
That's amazing. So what happened? When you increase the level, it just tells you is to turn it down, right? They just tell you, hey, it's too loud, please don't. And that helps, right? Well, does it help? Do you stop when they tell you to stop?
I never get to that in the first place. But
You never get above that.
Yeah.
That's amazing. You're not one of those.
Yeah, I'm probably not that.
Sorry?
It's maybe not that common. I don't know.
Yeah. The point is that many young will probably ignore it, right? They would just go like, well, I'm just about to listen to my best tune. I'm just going to crack it. Because guess what? As soon as you start turning up, that's when the message arrives. And that's probably too late. Imagine you're like, oh, yeah, I'm getting my best tune. Boom! You get the message. So anyway, This is definitely, don't get me wrong, this is definitely something that should be there. And it's not a bad message. We should be having those things in place. My concern is that maybe this isn't necessarily enough, okay? And I'll get to my points later. So the question that I have really is, why is that so many decide to listen at loud listening level rather than quieter listening level? What's the thing? What's the thing that drives them? What's the behavior that drives them to push the level up? Any guess? Adrenaline, right? Like speed, sugar, drugs, right? It's the adrenaline, the thing that gets you there. But instead, what we are doing is simply saying, too loud, quiet. So I'm going to show you, I'm going to explain what I think and what we think are the three factors that have led us to this situation, right? So the first thing is, well, technology. I know there's the Beatles, and you're like, what are the Beatles here for? So in 1965, 42,000 screaming wee girls were twice as loud compared to the Beatles sound equipment, right? So they were about 135 dBSPL, right? And the Beatles were using 175 watt amplifiers to amplify their sound system. Essentially, they were just watching them playing. They couldn't hear anything whatsoever, right? So obviously these days what happens is that we have, what we did is we made our sound system much more powerful, and we miniaturized it into small little headphones that we can just wear 24/7, right? And yeah, we can have now a concert all day long, anytime, anywhere. So the second factor is, well, the frequency content of the way we produce music, or in general, video games or movie, has changed over time, right? So what happened was that between, as you can see, like these are just examples, in the 1950s, this sort of was the frequency content that we could get, you know, roughly. And then as we get into the 60s, 70s, you know, we can see that we get more and more energy into the low and the higher frequency content, right? Why? Because equipment is getting louder, right? And is getting also better at reproducing certain frequency ranges that were not possible before. And so therefore also the way we make content has changed. We are putting more and more energy in those frequency ranges. And you know where this is leading now? The third thing is, the third factor is, well, sound perception. We're just, I'm sure most of you are familiar with this, right? And it's probably something that you learn, well, at uni or just by researching. And for me, it was such a revelation when I was just standing in classroom and I was seeing this for the first time. I was like, what? How come I didn't know this earlier? I know this is probably given for granted at this point, but it's good to revise a little bit what this graph tells us. So let's just get a simple example. We all know. So let's just get the 10th phone curve, and let's see, and compare it to the highest. Obviously, this is an extreme example, so it doesn't apply into real life, but this is just to prove a simple point. So the difference between the 3 kilohertz and 20 hertz at 10 phone is, let's see if you get there, come on. It's 80 dB, right? So in order for 20 hertz to be as loud as 3 kilohertz at 10 phone, this is obviously ridiculously, you know, it's impossible to hear that low. Of course, this is exaggerated. We need to increase by 80 dB, 20 hertz. Please, by the way, stop me if you have any question. I would like to take questions while I talk, okay? And in contrast, if we see the 100 phones curve, we only have to increase by 31 dB, okay? So between low and high listening levels, there's a massive difference between how much we need to increase low and high frequencies. Obviously, for this example, I'm only taking 2 frequencies. Now, if we compare the 100 dB phone curve with the 10 phone curve, right? So the difference between the two is it's 49 dB. So obviously, again, these are exaggerated, but the point is that between the 10 phone curve and the 100 phone curve, we have a difference of 49 dB in terms of discrepancies in frequency perception. What does this mean? What does this mean, in your opinion? So what I see is that, sorry, why are we getting here? Sorry. So these three factors really leads us to the conclusion that, hello? Okay, so we have technology. The better the sound system became at producing louder sound, the richer audio content became at low and high frequencies, and these feed to each other in a feedback loop. And as a consequence, we have the listener had to increase sound levels so that you can perceive those low and high frequencies that were put in the first place in the audio content. So what I'm trying to say is that we have frequencies that are better heard at higher listening levels. So it's only natural that we unconsciously increase sound levels, not only because it's exciting and we love the vibration in the club or whatever, but we have frequencies that are much better heard at higher listening level compared to low listening levels. And that is part of the story. And of course, I understand that we also increase levels to block noises, like the equipment, sound equipment became better, for example, from the Beatles, so that the crowd could scream, but you could still hear the music. I understand that is also the point, but there's a reason why 1 billion people prefer louder over quieter, especially when they're on their own with headphones, because they don't have much noise to block. They're on their own most of the time. So any questions so far? No question, cool. Let's go. So now, what are we trying to do here? So what we are trying to do here with Oikley is to try and have loud without being loud. And it might be contradictory at first. How can you have something loud but not loud, right? But let me give you an example of something that happens when we drink Coke and we have Coke Zero. And this is not an advertisement whatsoever, but this is just an example, okay? So you drink a Coke Zero. Not that I particularly like it, but this is just an example. It is sweet, right? And yet doesn't have any sugar. Oh, maybe not. You don't agree with that. Is it sweet enough for you? So, okay. Is it sweet enough for someone? Well, if it's there, it's because it's probably viable and people consume it. But the point is simply that we need to find maybe other ways to make the listening experience sweet, okay, but without the sugar content that maybe gets you to get diabetes, which is irreversible. And does it mean that you always drink Coke Zero? Probably not. You will probably switch back to the original Coke, which is your loud experience from time to time. But the idea is that from time to time, you'll probably use something that is healthier and satisfy you. Now, let's take a look at how it works. So my apology for the bad user interface that I built in Pure Data just to show how it works. So let me show you. So how our technology works. Sorry again for what you're saying. I tried my best yesterday. So here we go. So the first thing that we did was to model a filter that could filter audio. Let me just turn on the DSP here. 1 second. So the first thing that we did was, okay, the first thing what we need to do is to assess how loud something appears to be to the listener, right? Because if we don't know how loud it is, then we know what frequency perception the person is perceiving. So we'll build this filter which essentially interpolates between any of the A, B, C curves that you see on a weighting filter, right? Because the problem with those sound level meter, in our opinion, was that you have to select manually either A or C. B is no longer really in place. And depending on how loud it is, you need to switch between the two, right? But what we thought is we need to have a weighting filter that automatically adapts based on how loud the incoming signal is, okay? So let me just give you a simple example. The lower the listening level, the more it filters low and high frequencies, okay? And these are mid frequencies, by the way. And the louder we go, the less it filters low and high frequencies. And that's the same that happens when you switch between A and C on your weighting filter, okay? Why do we do that? Because we need to account for our lack in the perception, how our perception changes as we increase or decrease sound levels. Any questions so far? Okay, cool. The second thing that we need to do is, based on how loud something appears to be to the listener, we need to associate a specific sound level. For example, 80 dB, for example. This is your current sound perception, which is essentially an interpolation of all the loudness and all the curves that you saw earlier on the Fletcher-Manson from 10 to 100, okay? And the third thing that we need to do is, as a user or as a sound engineer, you can decide, okay, so I'm hearing at 70 dB SPL, but I would like to perceive it as if it was played at, say, let's just go for, this is my sound level 60, actual sound level. But I would like to perceive it as if it was played at, for example, 85, okay? What you're seeing here is the result of the frequency perception or the compensation that we need to apply to the signal in order to reproduce the same frequency perception that we would have if we were playing that audio file at a higher level. Make sense? Now, obviously, if I decrease my listening level, the more I decrease it, obviously, the more I need to compensate, right? And for example, in this ridiculous example, we have, I don't know if you can see from there, but we have, let me just zoom in. So we have, for example, at 20 hertz, we apply 20 dB. At 30 hertz, we apply 16 dB, and so on. Obviously, the more we get to the mid frequencies, the less we apply, okay? And now you might ask, well, we all hear differently. And you're right. We all probably hear differently. And the data that we use to make these calculations are based on the latest ISO 2003, which are essentially an average of 20,000 hearing profile from Japan. I don't know why they chose only Japan, to be honest, but fine. But we can all assume that despite we all hear slightly differently, we all exhibit the same differences between low and high listening levels. We all lack in low and high frequency perception, particularly low listening levels. Now the question I have for you guys is, why do we perceive more mid frequencies than anything else?
Human speeches.
Of course, I know it's probably an easy, super stupid question, but the point is that the reason why we don't hear low and high frequencies is because, for an evolutionary reason, I can talk to you, you can talk to me. So, any questions so far about this? All good? And obviously this happens in real time as I decrease or increase my level. That goes down and up. And let me also point out that this is not just a compensation upward, this is also a compensation downward, because also the opposite could happen. And you might ask, why would you have high listening level, like real sound pressure level, and then decide to have a lower sound, a lower virtual level? Why would you do that? Well, let's just say that we're in a video game. Okay, I'm playing a video game and I'm listening at 75 dB SPL, roughly. And there's a bird tweeting in my game 20 meters away from me. And that bird in real life would sound like as if, 60 dB SPL. Well, now, by having my sound level at 75 dB SPL, that bird is being distorted. Let's just put it this way. By changing the sound level, really what I'm changing is my frequency perception of what I'm hearing. And in a way, we can think of a volume of sound, actual real sound pressure level, as an equalizer, in a way. And you might think, well, yes, it is, right? Because as you increase, you get more and more of certain frequency. We saw earlier. Between low and high frequencies, we get so totally different frequency perception. So the reason why you would want to change it maybe to a lower is to maybe replicate, to have a perception of something that is lower in real life than my actual sound pressure level. So again, going back to my example of the video game, right? So how does it currently work? So I work in my studio, right? And I create my explosion sound, which is very loud in real life. We don't want to replicate that in real life because otherwise we really destroy our hearing. And what happens is that on the other side, on the listener side, based on how loud I hear it, I perceive it slightly different. So as a creator, if I create something here, the moment that the game is played or the moment something is heard on the other side, we have no control over the listening levels that they're listening at, right? So if they're listening at 70 dB, they get a safer experience, but maybe poorer because they don't get to hear all of those. Sorry, maybe boring. And as I increase it, of course, I get better experience, more immersive, but quite dangerous at the same time. So what I'm going at now is, now let's imagine the same process being applied to every single sound element in a game, right? What if we can decide, okay, I want the explosion this big, I want the gunshot at this perception, and so on. So the way what we thought is to, imagine we're in a video game and we want the gunshot to sound like 110 dB, right? And the background explosion to sound like 115 dB. Sorry for the minus, it shouldn't be there. I probably did something yesterday. And so we can decide how different elements in a game would sound like regardless of the end listener's volume. So how does it work? We embed all these sound perception, we embed all this sound perception as metadata into the audio file. This could be in Unity, Unreal Engine, whatever software we're using. And on the other end, based on the final listening levels, we can adjust each frequency content or frequency perception of every sound so that the creator essentially makes something that appears to be exactly like he wants, is not really distorted by the sound level at which you're listening to. So the next thing is that as a result, what we get is a much more enhanced listening experience, but at safer listening level, because we are not asking the listener or the gamer or the watcher, whatever that is, to increase sound levels to get or to unlock those frequencies that would otherwise be hard to hear at low listening levels, right? Because we put so much content in those frequencies that are better heard at high listening levels. Simple as that. And we tested it. We didn't test it. We what we did is we recreated a full video game, not ourselves, we just took a video recording screen of a video game, Destiny. We recreated all the sound design, all the music and everything, and we applied our perception, on every single sound. And we tested with 115 people. And we let them hear the original version and then the process version. And at the end of it, what we found was that 85% of them felt that they didn't need to increase sound levels when they were listening to the process version versus the original one. And the second thing was that they were happy with their experience when it was processed. And it's not just that, going back to my Coke Zero example, we need to find other strategies to change the 1.1 billion people's behavior. Because it's not about stopping people from, hey, this is too loud. They're probably going to rebel and be like, you know what, I like how loud this is. I don't care. I'm just going to fuck my ears up. Sorry for swearing. But we need to find different strategies to actually make them enjoy listening experience at safer listening level by making it as if they were listening at louder listening level. Please.
So on the
Finally, one question.
On the last slide, you kind of mentioned some metadata. So are you actually encoding the source stream?
Yeah.
Okay.
So that's the plan. We haven't done it yet, but it is that you would encode within the audio file directly 85, 85.5, whatever that is. That can go between 0, which is stupid, to 110. But these are the data that we have available from the equal loudness curves, the latest standard. It doesn't go any beyond, obviously, and below 0 because it would be stupid. So yeah, you can encode every single of those metadata within every single file. Like within every single audio, whatever that is, can be a whole mix or a single audio file, a group, whatever. You can just encode every single one of them. And as you decrease the level, you get the same compensation going up or down. Please.
So, yeah, I have a question. How do you know the actual?
That's a great question. Of course.
Level, because you don't know what's downstream of
No.
the user's impulse or computer.
So we're talking speakers or headphones? Any, right?
Whichever.
So when it comes to speakers, there's a calibration been done before. So first of all, to do the calibration, we use the on-the-board microphone on your smartphone, and we apply the same weighting filter that I showed you earlier, the dynamic weighting filter. So after the calibration, we can determine how loud it is at the listening position. And you might ask, what if I change the level, right? How do you know that? We use ultrasound. So we project ultrasound through the loudspeakers. We pick them up with the microphone here. And based on that, we can detect how loud something is. Because the problem was that, well, OK, what if I'm listening at 60 dB and then I'm talking to a friend of mine? Then the microphone will pick up my voice, and therefore it would think that it's louder. And so by using ultrasound as a signal to control, to determine what the level is, then we don't have that problem. Because I can unless you clap, then you get some ultrasound. But one step at a time. So that's how we do with loudspeakers. But when it comes to headphones, we'll have this similar approach to SonarWorks, meaning we'll calibrate every single model in studio, and we'll have a catalog. And based on the catalog, you have different profiles. And you might ask, well, what if I change the sound card and so on, right? And you'll be right. So there's some challenges with headphones. But maybe, the good thing is that many headphones have, some of them at least, have internal microphones. And another thing is that many headphones these days are Bluetooth. So they're not connected necessarily to a different amplifier. So when you make a profile for a pair of headphones that are Bluetooth, then it's done. I'm happy to go deeper in this topic if anyone has any other question. Cool. Right. By the way, I'm just changing. This is a clicker. So anyway, if you would like to try the demo, please scan this, and I'll be happy to send you the demo so you can try it yourself. Usually the system should be calibrated, but it's best on headphones, so I don't have 25 headphones here. I don't know how many you are, but it's enough. So if you haven't checked my website yet, please feel free to go and check it. We have plugins, one plugin for now. And next year we'll have our flagship product, which will be Perception, which is what I just told you. Essentially is a way to monitor, to recreate virtual sound levels at safer listening level, right? So you can just you can monitor something at roughly 70 dB SPL, but perceive it as if it was played at 85 or whatever you prefer, right? Yeah, that is it. My final statement is that, everybody should enjoy exciting and, safe listening experiences, right? More than ever. So if you think that this is something that is relevant, and it should be relevant, to be honest. I mean, safety should be the first thing. And I don't think we want to end up with a lot of people risking hearing loss in the future. So if we want to, continue having music and stuff like that, safety should be one of the first things that should be in place. But not in the traditional way where we say to a kid, oh, turn down the volume. What about my experience? What about the excitement? I mean, the genie's out of the bottle. Like, people love loud sound music. How are you going to stop them? if we force them to not have loud music, I'm pretty sure there will be pushers like, hey, I have a pair of headphones that go loud. Like, I'm obviously joking here, but the point is that we need to do something about it. Am I saying that my approach is the only way to do it? No, I think that it's one of the solutions that should be there, right? In fact, in the main product, we also have other features such as when you go too loud, there will be a push notification. When you've been listening for too long, hey, hearing fatigue, why don't you take a break, a 15-minute break? And during the break, we will lower the level. When you come back, your hearing is a little reset, and then you can do A/B between what you were listening before and after, so that you can train yourself. Oh, wow, I was listening that loud before? Wow, okay, maybe over time I should turn down my level. And you have also the option to virtually perceive it louder than it was. Thank you for listening.